not only for the tower, but also for the personnel. The development of wind turbines has gone through a whole range of stages. The wind turbine, as we know it, has only been around since the end of the 19th century. It was the American Charles Brush who in 1888 built the first windmill that generated electricity. That windmill had an output of 12 kilowatts. Nearly 120 years later, the average capacity of a wind turbine is more than 200 times higher. Although the idea of generating electricity using wind energy has been around for more than 100 years, it was not until the mid-1970s that the power companies started to become seriously interested in building wind farms. By then it had become clear that fossil fuels, after taking industrialization in Europe to such great heights, were soon going to be depleted. The oil crisis of 1973 and the Club of Rome report generated a growing interest for alternative sources of energy. Yet quite a few people are opposed to wind energy. Amongst other things, they draw attention to the high cost of the energy that is produced, which at the moment is more expensive than electricity generated by fossil fuels. Recently, however, due to the ever-increasing price of oil, the balance has been changing in favor of wind turbines. Research shows that in the right locations, the world's electricity consumption can be generated by wind power for less than $7 per kilowatt hour. A standard wind turbine begins to produce electricity at wind speed 2 to 3. At wind speed 6, the turbine will reach maximum power output, and it will continue to do so up to wind speed 10 or thereabouts. On average, a 1200 megawatt wind farm will produce around 500 megawatt per hour. That is sufficient to provide 750 households with the electricity they need. Installing the blades is another story. Basically, it can be done in two ways. Either you mount the blades to the head while it is still on the ground, or you can attach them when the nacelle and head are already mounted on top of the tower. In this case, the installation crew chooses the second option. Two mechanics have climbed all the way up and are in the nacelle waiting for the first rotor blade. This blade is being prepared by their colleagues for the long journey upwards. The large spreader must ensure the blade ends up straight in front of the rotor aperture. Long lines are attached to the tip. These lines will be manipulated later from the ground. Finally, the screw thread is greased to protect it against corrosion caused by wind and rain. The life of a wind turbine is a real battle against wear and tear. It is exposed to the elements 24 hours a day. A turbine will usually last around 20 years. After that, it is destined for dismantling and recycling, but not before the rotor has turned millions of times. Of course, an advanced piece of technology like this will regularly need maintenance. But all being well, this blade will not come down to Earth before the year 2025. But first, it has to go up. Once again, the motto is, easy does it. The crane operator stays in touch with the mechanic in the nacelle by means of a walkie-talkie. He passes on information about the position of the blade. Centimeter by centimeter, the rotor creeps to the top, where it will do its job for the next 2 decades. Whether wind energy will be the norm by the time this turbine is replaced remains in question. For the time being, wind energy is still a secondary source of electricity in Portugal. There are still too many problems in fully converting to wind energy. But here too, the number of turbines is increasing rapidly. While in Portugal the final touches are made to the wind turbine, 1,800 kilometers to the north, late at night, a convoy of 5 combinations with new turbine segments is leaving a rest area near Wildeshausen along the German motorway. These segments are on their way to Geeste, a small village near the Dutch-German border. The transport of oversized loads in Germany is subject to very strict regulations. The convoy is only allowed to travel at night. The drivers have slept during the day and now drive to their destination in the dark. This means they cause minimal inconvenience to other road users. It's not unusual in the wind turbine transport business for the transport of one single turbine to be carried out by several transport operators. In this case, the vehicles of Rijksson Transport from Rhenen amicably follow the vehicles of Terlinden from Doetinchem. On this occasion, a mega windmill transporter had to be hired to transport the bottom section of the turbine. So they gave Terlinden a call. At the time, Terlinden was the first Dutch transport operator to buy a Notenboom mega windmill transporter. It was no problem carrying the other segments on Notenboom low loaders and semi-low loaders. After driving for 1.5 hours, they leave the German motorway. From here on, they will have to travel on A roads and minor roads. During this part of the trip, the column of vehicles has a German police escort to give extra assistance at crossroads and when passing through villages. There are plenty of villages and crossroads to negotiate on this trip. It gives the men from Ter Linden and Rixen the opportunity to demonstrate what the Notabone trailers can do as far as maneuvering is concerned. The mega windmill transporter performs particularly well. Owing to the turntable that connects the lift adapter and self-steering dolly, the rear section can form an angle of almost 80%. This means unprecedented maneuverability, which is useful for this kind of transport on minor roads. The mega windmill transporter also comes into its own on the many roundabouts that have to be negotiated. With the hydraulically adjustable lift adapters, the load can be raised up to 1.5 meters above the road surface. Curbs, roundabouts with raised rims, central reservations and even crash barriers are no longer a problem. Not that the drivers encounter many obstacles. The route has been meticulously planned, and apart from a few roundabouts and sharp bends, the vehicles are able to proceed unhindered. When the trailers of Ter Linden and Rixen arrive in Geeste, work is in full flow in Troje, formerly in East Germany, where another turbine is being installed. Here, a stone's throw from a nuclear power station, the existing wind farm is being expanded with 23 new turbines. The installation crew made an early start because it's going to be a long day. The parts that arrived during the night have to be unloaded first and then assembled. In contrast with the crew in Portugal, the German supervisor decides to attach the rotor blades to the head before assembling the tower. The head and blades are then mounted onto the nacelle. In Denmark, 20% of electricity is produced by wind, proportionally the largest amount in the world, but Germany is the country with the most wind turbines. They have installed more than 16,000 megawatt of energy in total, and it is increasing all the time. Particularly in the former East Germany, new turbines appear nearly every week. One by one, the blades are moved up and unloaded. 2 mobile cranes are needed to position the blades right in front of the rotor head. Subsequently, the protective covers are removed from the screw holes and the blade is bolted onto the rotor head. Every bolt is tightened by hand. The end result is a rotor with a diameter of more than 60 meters. It is carefully lifted up and put to the side. Now it is the turn of the tower sections. They too are moved up one by one. Because these tower sections have been transported with a mega windmill transporter, they are unloaded in no time at all. As soon as the clamps of the lift adapters are uncoupled, the connecting pieces are tightened and the tower section is slowly lifted into position. Positioning the tower sections is a painstaking, time-consuming job. Although the parts fit together securely, they must be positioned just right, accurate to the millimeter. This would be tricky enough on the ground, but at a height of 80 meters, this is a heck of a job. The higher up you are, the stronger the wind blows, which doesn't help at all. The same wind that will provide the energy to generate electricity is your worst enemy in this stage of the assembling procedure. When building a wind farm, the position of the wind turbines in relation to each other must be taken into account. If they are too close together, the turbulence generated by the movement of the rotors could reduce the output of the other turbines. How much space there should be between the turbines depends on the length of the rotor blades. But the geography of the landscape also plays a role. The wind behaves differently on a plain than in the mountains. That doesn't mean that turbines should not be built in mountainous regions. Wind farms in the mountains can be very efficient. The shape of the mountains and valleys create a funnel effect, whereby a wind blowing through the narrow passages is more powerful than a wind on an open plain, even if the wind speed is the same. When the tower sections are assembled, it is time to mount the nacelle. The nacelle is first securely clinched. Then the lines are attached so the position of the nacelle can be adjusted if necessary. When the nacelle is lifted, the turntable underneath is clearly visible. This turntable ensures the rotor will always face the wind. It is not just the nacelle that turns. The rotors themselves can also be adjusted. When the angle in relation to their vertical axis is slightly altered, the airflow around the rotor blades will change. Nowadays, this is all done automatically. A computer in the nacelle constantly monitors the speed and direction of the wind. In this way, the turbine itself ensures that the rotor blades are always facing the wind at the most favorable angle, so that the turbine operates as efficiently as possible. When the rotor blades are adjusted, the pressure on them changes accordingly. This changes the rotor's turning speed and that of the gearbox in the nacelle. This gearbox is much like a gearbox of a car. The rotation speed of the rotor is actually too low to make the generator turn at the required 50 Hz. The gearbox ensures that even at low speeds, the generator makes enough revolutions to generate electricity. Wind energy is as old as man. Our ancestors were sailing ships round the world long